All right, guys, we're going to move on and talk about proportions. A little different type of solving equations type work. But we're going to get away from our literal equations and our unit analysis and get into solving some proportions. The stuff that you've seen before, just need a memory jog, and we're going to talk about how that applies to similar figures. We're going to talk about geometry just for a minute. So we need to solve and apply proportions and then find missing lengths in similar figures and use them to measure indirectly. Okay, there's our standards. Now, we need some vocabulary first. A proportion is an equation that states two ratios are equal. Now, what are ratios? Remember that from last section, a ratio compares two quantities by division. In other words, the fraction, right? So a ratio of 1 to 2. That's a ratio. The second I write that it's equal to 2 to 4, that becomes a proportion. Okay? So it's two ratios set equal to each other. So that the two ratios are supposed to be equal. Okay? Similar figures. Quick geometry lesson, similar figures are two figures that have the same shape, but not necessarily the same size. So for example, two rectangles where one is bigger than the other one. Those would be similar because they're the same shape, but not necessarily the same size. A scale model. Scale models are used all the time. It's a three-dimensional model that is similar to a three-dimensional object. Now, what we haven't said about similar figures is that their sides, their lengths, their measurements all should be proportional to the actual, to the larger shape. So for a scale model, let's say for the Student Activity Center that's being built currently, someone had to come up with a scale model so that we could see how it's going to look when it's attached to the high school, see how its heights and widths and all that kind of stuff would be in proportion to the high school. So that's what a scale model does. It's a representation of a three-dimensional object. And then a percent, because we talk about your grades all the time, right? Your grade is a percent out of 100. It's a ratio. It's a number of points out of 100. Okay? So let's get into proportions. This is a proportion. This is saying that the ratio of 16 to 4 is equal to the ratio of 12 to x. Okay? So 16 to 4 is equal to 12 to what? Well, you may be able to think through this and figure out what x is supposed to be. But we're not going to be able to do that for every type of proportion. So this is a proportion saying that these two ratios should be equal. So to figure out how they're equal, and this kind of comes from how we clear fractions, but I don't really want to get into that too much. But what ends up happening is if you cross multiply, then those products must be equal. So if I take 16 times x and get 16x, 4 times 12, which is 48, then those two products must be equal. It's a property for proportions. That just means all I got to do is divide by 16 now and find out that x is 3. Okay? All right. And the reason why we need the process is for something like this, where we can't necessarily think our way through for finding c. So what we do is we do our cross multiplying. 2 times 5c is 6c. 5 times 3 is 15. Then divide both sides by 6. And then we can reduce the 15 over 6 to 5 halves, which is going to be 2.5. Which for a proportion of 2.5 probably makes more sense. Okay? Try this guy. See what you come up with for m, and we'll go on from here. Okay? Did you get 45 over 8 or 5.6? Okay, cross multiply, and that's what you should get. Okay? Now, proportions can get a little bit more complicated. We can have more than one term in either numerator or denominator of our ratios, or both, or whatever. So what we have to understand is, when we're cross-multiplying, we're taking all of this numerator times all of this denominator. So 6 times negative 1 is negative 6. And then we're taking all of this denominator times all of this numerator. In other words, we got to distribute that 3. 3 times x is 3x. 3 times 8 is 24. Right? So now we're going to subtract 24 from both sides. And 3x equals negative 30. Divide both sides by 3. So x is negative 10. Okay? The biggest part of this is make sure that you distribute when you have more than one term in either a numerator or denominator anywhere in your proportion. Make sure that you're distributing whatever you're multiplying by. Okay? So try this guy and see how it goes, and we'll move on from here. So, did you get this? Again, make sure you distribute. So 10x minus 20 is going to be equal to 4x plus 40. And go through and solve for x the way you know how. And so x should be 10. All right? Got one more. So go ahead and cross multiply here. See what you get. Start the video back up to see how you did. Should have gotten negative 1.5. Again, making sure that you distribute the 6, and then you can see how I solved from there. So make sure you're getting these, and if you're not, come in and see me and we'll figure it out. But that's how we're solving proportions. Okay? Now, how do we use them? Well, here's one idea behind using a scale model, which we defined earlier. You want to make a scale model of the clay horse you saw in a museum. The clay horse is 1.5 meters tall and 2 meters long. Your scale model will be 18 inches long. How tall should it be? Okay, well, a proportion takes two ratios and sets them equal. So it says that two ratios are equal. A ratio is a way of comparing two quantities, right? So here's what you need to do to you're going to need a proportion here to help find out how tall your scale model should be. The nice thing about proportions is, as long as your two ratios compare the same things, then you can set them equal and you can find whatever you need to find. You may set up a proportion differently than I do. It depends on how you see it. There's a lot of ways to set up a proportion to solve for what you need. But here's what I see in this one. I think if I can compare the height to the length of the actual clay horse, so I would get 1.5 meters to 2 meters, then that's going to have to be equal to the ratio of the height to length of my scale model. Now the height I don't know, so that's going to be x. The length is 18 inches. Right? Those two ratios are the same. If I compare height to length in both the clay horse and my scale model, then they should be equal if it's going to be a true scale model. Now I can cross multiply, then divide by 2, and we get 13.5, so that means that my scale model should be 13.5 inches tall. And I don't want to answer that in a complete sentence. Okay? All right. Now, these similar figures, how does this work? A couple of quick things from geometry. This is what's called a similarity statement, and it's written with a purpose. The similarity statement should tell you how the two triangles match up. Right? So they've got two triangles here, triangle ABC, triangle XYZ, and they're similar, which means that their sides are proportional. Which means that we should be able to write the ratios between the corresponding sides, and all those ratios should be equal. Well, sometimes you can tell just from the diagram, just how the triangles are sitting, which sides match up. Sometimes you can't. So you can use this similarity statement. This is what's called, like I said, a similarity statement. So in other words, I know that AB, side AB, is going to match up with side XY because of where those sit in the names of the two triangles. So that tells me that side BC must go with side YZ. And last but not least, side AC must go with side XZ. Okay? Each of those ratios I should be able to set equal to each other because they should be equal if these are similar. Now, I can fill in the measurements here, 6 to 9, and then 8 to 12, and then 10 to x. And then any of those two ratios we can set equal. And then cross multiply because it's a proportion and solve for what we need. So I can go ahead and set 8 over 12 equal to 10 over x. Cross multiply and get 8x equals 120. Divide by 8 and realize that this is 15. So that missing length, xz, is 15. Okay, that's how similar figures work and how they help us find missing lengths. Okay? Can you write the ratios, the corresponding side ratios, and then figure out how to set them equal to each other to find what you need? Try to set it up, and I'll show you what you should have done in just a second. Okay, so here are your ratios. Okay, and then I need to set two of these equal so I can find my variables, my missing lengths, right? And so yz, the length of that is going to be y, and the length of xy is going to be x. So if I set these two guys equal to each other, cross multiply and solve, I get 5y equals 30, and then divide by 5, and y is 6. So this length is going to be 6. Then I can take 4 to x instead equal to 5 to 10, cross multiply, get 5x equals 40, divide by 5, and x equals 8. And so this length right here is going to be 8. And so again, that's it. Using similar figures, that's how we go about doing that. Okay? Right, you got two similar trapezoids here. How would you set up the ratios to find x? Okay, how'd you do it? Hopefully you took 18 and compared it to the 30, because those are your matching sides. And then the 39 and compared it to x. Those two ratios should be equal if these guys are indeed similar. So now we cross multiply. 18x is equal to 30 times 39. So 1170. Then divide by 18. And so x ends up being 65. So the length of that side x is 65. Okay? And so we're just matching up those corresponding sides. All right. Last but not least, we've got this story problem here. And this is actually pretty neat. If you haven't tried it, you ought to sometime. If you want to know the height of a tree, okay, it's very difficult to grab a tape measure and try to go to the top of the tree and measure it to the bottom, to the ground. So what you can do instead is set yourself up in a particular way. So here's what I mean. A student who's 5.25 feet tall is standing next to a tree, and there are shadows involved. So the sun's shining here, and we've got some tree. And this tree is casting a shadow. The shadow is 80 feet long, and the tree, we want to know how tall it is. Well, you could position yourself, and you should do it so that you're like right here, basically, so that your shadow matches up with the tree's shadow. Now, I'm not going to continue drawing it like this. I'm going to pull this out so we can see it better. But if you're standing here, that's a weird drawing. Well, anyway, you're going to cast a shadow as well. Your shadow is 20 feet long, and you are 5.25 feet tall, right? And you can use whatever your height is and whatever the length of your shadow is. But it's a lot easier to measure the shadow on the ground than it is to measure the height of that tree. Now, for reasons that you don't need to really understand just yet, you'll need to when you get to geometry, but these two diagrams end up giving you two similar right triangles. So we can write a proportion to these corresponding parts, these corresponding sides. So x to 5.25 is going to equal 80 to 20. Then we're just going to cross multiply and solve and realize that 20x equals 420. And then when we divide by 20, we get 21. So that means that the tree is 21 feet tall. Easy enough to find. Okay, but kind of a neat trick to try to find the height of a tree. Okay, that's it. Your homework's out in Canvas. Make sure you get that done by next time.